All right, let's look at a few questions from chapter 10a. The equation of the tangent and the normal to the curve y equals 2x plus 1 to the power of 9 at the point 0, 1. Well, the equation of the tangent and the normal. So let's just find the equation of the tangent first. So dy dx will give us the gradient of that tangent. 9 comes down, multiplies by the bracket, the power of 8, and then times by the derivative of the bracket is 2. We've got 18, 2x plus 1, power of 8. Now, when x equals 0, m will equal 18 times 2 times 0 plus 1 to the power of 8. So we've got 18 times 1, 18. Therefore, y equals mx plus c. Y equals 18 is the gradient. And to find the constant, we substitute 1 and 0 to get the constant. So 1 equals 18 times 0 plus c. Therefore, c equals 1. So the equation of the tangent is y equals 18x plus our constant 1. Okay, that's the tangent. Let's find the normal. If the tangent gradient is 18, then the gradient of the normal is negative 1 over 18. So we substitute that into y equals mx plus c. Replace our y value with 1 and our x value is 0. We get negative 1 over 18 times 0. Therefore, c equals 1. And so our y equals negative 1, 18x plus 1. That is the normal. All right. Question 6. Find the equation of the tangent and the normal at the point x is, okay, same situation. dy dx is 2x. So at x equals 1, the gradient will equal 2 times 1, 2x. So our gradient is 2. So y equals mx plus c becomes y equals 2x plus c. What is the c value? Well, we need to substitute, find out what our y value is, and at x equals 1, y equals 1 squared minus 2. You use this equation for y equals x squared minus 2, so negative 1. So that's the point 1, negative 1. All right, so put in negative 1 for y in here. Put a 1 for x and find constant. So negative 1, therefore c equals negative 3. So the equation is y equals 2x minus 3. That's the tangent, part 1. And we want now the normal. The normal, if the gradient of the tangent is 2, still a different color. Let's do the normal. If the gradient of our tangent is 2, then the gradient of the normal is negative 1 over 2. You flip it over, 2 over 1, 2 over 1, negative 1 over 2. So y equals mx plus c, and it's the same point, 1, negative 1. So y is negative 1, x is 1. So negative 1 plus a half equals negative a half. So the normal, part 2, is y equals negative a half x plus negative a half. Okay, that's 6 part A. Let's do 8A. On the equation and of the tangent only when x is 0. Well, if x is 0, what is the y value? Because we've got to find the point to get the equation of the line. If x is 0, y equals 0 squared minus 1 over 0 squared plus 1. So you get negative 1. So we're dealing with the point 0, negative 1. Now let's get the gradient, and we need to get the derivative. So u is x squared minus 1, and v is the denominator, x squared plus 1. So u dash is the derivative 2x, v dash is the derivative 2x, and the y derivative, dy dx, using quotient rule, is v u dash minus u v dash, v dash, not v dash over v squared. So v is x squared plus 1, u dash is 2x minus, u is x squared minus 1, v dash is also 2x, v squared is x squared plus 1 squared. Okay, substitute 0 when x is 0, that x equals 0, our gradient will be, substitute 0 in here, 0 squared plus 1 times 0 minus 0 squared minus 1 times 0 over 0 squared plus 1 all squared. Our gradient will also be 0, 0, 1. Gradient is 0. If the gradient is 0, it's y equals mx plus c, y equals 0x plus c, and substitute negative 1, 0 in there. Therefore, it's y equals negative 1. The equation of the tangent is y equals negative 1. 0, negative 1. 9, let's just do 9b. Find the equation of the tangent at x equals pi over 2. Well, we need the y value. Y is cos of 2 times pi over 2 is negative 1. Negative 1. And the gradient is, you have to get the derivative and substitute x is pi over 2. So first of all, what is the dy dx? The derivative is negative cos, negative sine 2x times 2. So I'll just multiply that by 2. Substitute pi over 2 in here. So we get negative 2 sine of 2 times pi over 2 is pi. And sine of pi is 0. So the gradient is 0. So it's y equals 0x plus c. Substitute x pi over 2. Substitute y as negative 1 because we found y as negative 1. Therefore, negative 1 equals c. So the equation is y equals 0x plus c. It's a negative 1 also. Same answer as question 8a.